Hello, I'm Jamie Dobson, the founder of Container Solutions and the host of this podcast, The Cloud Native Attitude.
And I'm Ian Mile, the co-host of this podcast, author and partner at Container Solutions, where I work with Jamie on complex cloud problems.
Now, this is a strictly limited edition podcast. We're going to be talking about the why of Cloud Native as well as the how and the what. We are going to be joined by industry experts and by real people from real companies who have both succeeded and failed with cloud. So make sure you follow me and Ian over on LinkedIn to keep up to date with announcements. In the meantime, Ian, should we get this show on the road?
Yes, let's.
Welcome to the very first episode of the Cloud Native Attitude. Now, if you think that today we're going to be talking about microservices, Kubernetes, and all of that technical stuff, you're going to be rather disappointed. That's because today, with it being our first episode, is all about the why of Cloud Native. Why do companies do it, and how should a company start depending on how big it is, if it's scaling up or speeding up. With that note, I now say hello to my wonderful co-pilot, Ian. How are you doing?
All right, Jamie. How are you?
I'm all right. I'm a bit tired. Been on a train all night.
Oh dear, all night.
Not exactly all night. 2 hours from Brussels to London. It felt like all night.
Not the Orient Express, then.
No, I wish. Does that even exist anymore?
I don't know. My parents met on it, though. That's interesting fact.
Did they really?
Yeah, it was third class. Donkeys throwing up in the back, that sort of thing. But it was technically the Orient Express.
Was anybody murdered on that trip?
Not
No,
that I
it
know
was,
of.
it was a love story version. Right, Ian, what are the things we're going to be getting into today, mate?
So, I guess the first thing to tackle in your book is what is cloud native, right?
You know what? I got asked this question the other week at a meet-up in London, and I actually said something along the lines of, it was genius what Anne did. So before she got into technology, when she first structured the book, she
And is
spent
your
the first...
co-author, right?
Anne is, of course, the cohort. Well, actually, she's the main driving force behind this project. We're going to get into the history of the book at some point in this podcast. But the genius thing she did was to put two chapters at the very beginning. The first one is, of course, the introductory chapter. And the second one, I should know this off by heart, shouldn't I? I'm flipping through the book now. The second one is called the Cloud Native Quest. And what she does really smartly is focus on why. So forget about the how for the time being. Why are you doing this? Because it's such a difficult a thing to do. Make sure you understand.
Okay, yeah. So, I mean, I guess we see that a lot, don't we? We see companies coming to us and saying we want to be cloud native, but they haven't thought about why, or rather, they often think it's an easy thing, right? Because it's better. Cloud native is good, right?
I mean, right back in the very beginning, what you saw quite a lot of was engineers would nick the boss's credit card, or maybe they had their own credit card they could use, and then they would set up a bit of cloud infrastructure, terraform the hell out of it, put everything in containers and chuck it onto a Kubernetes cluster, and it was a simple stateless application. So, talk about over-engineering and making sort of a mountain out of a molehill. But people did that because they were really, really interested in the technology.
Yeah, they did. And I think this is a pattern we see across, since the very inception of technology itself, right? You have early adopters who are disruptive, who don't follow the traditional rules, stick it on their credit card, hope they don't get found out, hope they get forgiven, rather than what's the phrase? Ask for forgiveness, not for permission.
Ask for forgiveness and not for permission. It's really interesting. You've just reminded me. So you've probably heard the story, haven't you, that a person's walking down the street and there's a few people working on what looks like a wall or a building. And the fella says to the first person, "What are you doing?" He says, "Oh, I'm just laying bricks." The second person says something along the lines of, "Oh, well, I'm crafting these stones into this amazing wall." And that person is really into the task of building the wall. And eventually they speak to the third person who says, "Well, I'm building a cathedral." Now, why am I telling you this story? Because it's such a well-known story that it's actually a bit of a cliche. Well, Peter Drucker, my favourite writer on management, said he had no problem with the first person and the third person. He said it's that bloody one in the middle you've got to watch out for. And this is the reason. If a person is building a wall and he or she is doing an honest day's work for honest day's pay, great, transactional. We get a wall, that person gets the salary. If somebody thinks they're building a cathedral, awesome, they're going to be in it for the long run. He said, but the problem with the craftsman who was interested in the bricks and the mortar and the cement and his techniques forgets that he's building a cathedral and wastes all of his time improving his technique and never actually getting the job done. If that doesn't sound like a computer programmer or an engineer, then I don't know what does.
It also sounds like a guitarist to me. So
Right.
I've been a musician in the past, not a professional one, but an amateur one. And as a guitarist, you can get so into the technique that you forget, and so impressed by others' technique and wanting to prove your own technique, that you forget that you're trying to make people happy through music. You're trying to entertain
Right.
them or provoke emotions.
Yeah.
And that's very easily forgotten. And I think there's a good analogy there for what we do.
So when I'm writing, I tend to go back and look at sentences. And last year I spent about, I think maybe nearly 3 months on two chapters I was working on, tweaking, messing around. And when I took a step back, those chapters didn't fit in the overall arc of the book. They're now in the trash can.
Right,
So the,
right. I
so
mean,
this was a huge error.
we're talking about an architectural challenge, right, aren't we? We're talking, architects have to think about this stuff all the time. They can't just think about what is the best technology. In fact, there is no best technology. We all know that. They have to think about the context in which that technology is used. And back to the cloud, if you're a top engineer, talented engineer at a company, full of people who are ingrained in the on-prem traditional world, and you say, "Hey, we've got to use lambdas and move to the cloud," that's much more difficult to succeed with than if you're in a company where everyone's sort of familiar with the concepts already and
Yeah.
understands it and wants to go there and sees a reason to go there.
And I
Years
think that,
ago, I tried to introduce Erlang to a company. Now, Erlang is a distributed programming language with a very different syntax to C-based languages and a very different paradigm. And I was absolutely in love with it. And I
beautiful
thought this,
language.
yeah, and I thought this was the answer to, well, it was the answer to a lot of our architectural problems. But the challenge was that everyone in the company, bar two or three people, and this was a company of 700, were just in the C paradigm, in the C Java
Yeah.
paradigm, and the procedural paradigm, and getting them to shift was way harder than I thought. Way harder than I thought.
Yeah, people, it's interesting. So software is too soft. You can experiment too quickly. Architects have to be more careful because even though buildings begin in the imagination and then end up, they progress through paper, eventually they hit the real world. And what exists in the imagination doesn't is not always physically possible. You have laws of physics and gravity. The problem with software is it's so easy to get started that you can chuck up a prototype exactly like an architect can't throw a prototype building up. Which is not to say they don't use prototyping techniques. It's just too easy to quickly get in a kerfuffle with software. Um, Now, speaking of kerfuffles, Ian, we better let the listener into what is the why of the cloud native.
Hmm.
So this was Anne's genius bit. The three things to focus on, because Kubernetes cloud native, it will not be for every company and it will not be for every software project. Not every piece of software needs to be on a cluster on public cloud infrastructure. So let me hit you with it. The three reasons were: number one, speed. And what we mean by that is velocity of features. So if you want to go quickly from having an idea late at night, you're a product owner, and put it into the hands of a customer, this is what we mean by speed. It's sometimes called time to value, TTV, but I find
Hmm.
that such a boring managerial acronym that I rarely use that. Now, the second thing was about scale. Now, most people think, oh, you mean web scale stuff. And that's true. We sort of mean web scale. If you have 1,000, 10,000, 100,000 users, you need to be able to scale your software, which if you're only a software business, an internet business, software is the business. So as you scale your systems, you're scaling your business because you're able to onboard more users. However, it of course also means to scale down. You need to be able to scale up quickly to meet demand, and you need to be able to scale back down. And then this is the kicker, and this is the most controversial one. It's about profit margin. That's the third thing. You have to do this in the service of generating revenues whilst you are driving down your costs. And that bit is actually really hard to get right with the cloud. But it is one of the reasons why companies do it.
And often you need a scale to get the margin, right? Because if you're doing a little script, just write a bash script. You don't need to turn it into a multi-part Lambda process, turning a serverless process, uh, moving data into DynamoDB and then picking it up off a queue. You just write the script in a monolithic fashion. So you need that scale to get there, to get to that margin, right?
Yeah, well, that's exactly right. I think at the back of the book, and of course, this leads to the definition of, well, what is cloud native? And I think I somehow managed to leave this to the very last page of the book, where in the acknowledgements, I say something. Let me just put my glasses on because I'm an old person nowadays and I need my reading glasses. Um, but listen to this again. This is my acknowledgements. Where are we? So basically, I mentioned those wonderful microservice oriented, container packaged web scale applications that took advantage of the public cloud. I always loved this definition. Cloud native was container packaged, microservice orientated, and it worked at web scale. That is, after all, why the cloud was invented. And so, as coming back to what you just said, as you get product market fit, as your product starts to build traction, and then you onboard more users, it's through that mass scale, web scale, that you then start to drive record revenue. And if you're using automation heavily, if you're using the cloud properly, in other words, you will drive increased profit margins.
Yeah, I guess it's about getting the technology out of the way so you can just focus on increasing your business. I mean, that's one big aspect of this, right? I mean, I like whenever people ask me about what is cloud native, I always refer them to the CNCF definition, um, which I'd like to read out as it's quite.
Is it the present definition you're going to read out or an older version? Because they do change it, don't they? They update it every now and then.
The one I've got is the one from it's the markdown file in the CNCF um, root uh, repository, right? So, okay, so here it goes, right? Cloud native practices empower organizations to develop, build, and deploy workloads in computing environments, brackets, public, private, hybrid cloud, to meet their organizational needs at scale in a programmatic and repeatable manner. It is characterized by loosely coupled systems that interoperate in a manner that is secure, resilient, manageable, sustainable, and observable. Cloud native technologies and architectures typically consist of some combination of containers, service meshes, multi-tenancy, microservices, immutable infrastructure, serverless, and declarative APIs. This list is non-exhaustive. And what I really like about that definition is that it's very careful not to mandate anything. It
Yeah,
talks about
yeah,
what things typically consist of. It talks about characterized by loosely coupled systems. It talks about meeting their organizational needs at scale. So it's not actually saying cloud native is containers. You've got to use containers for cloud native. You've got to use serverless. Um, it is cloud, so public, private, hybrid. You need to be using a cloud infrastructure to do this, but you could do it on-prem.
yeah.
You could do
Understood.
it.
But you do, yeah, understood. But you'd use the same techniques to scale up your on-prem systems as you would your systems in the cloud. I actually love that definition. I don't like the word empower. That would be my only feedback. As soon as you hear the word empower, my mind immediately started to close down. But I've said to myself, keep an open mind. And actually, I think they've got that dead right. It's the quality without a name, isn't it? I don't know if you
Mm.
know about the concept of quality.
No, go on.
The quality without a name was an idea from Christopher Alexander. He was an architect and he wrote the first pattern language. He more or less invented pattern languages that are used extensively in software and hardware. And when he talked about the design or a design pattern was a known solution to a real world problem. And basically he said if I collect all these patterns and very importantly explain the context in which they work, then amateurs will be able to design their own buildings. So he said the best example he gave of this was a bus shelter. It's a pattern and the context in which it works best is on the side of a road. Don't put a bus shelter in your back garden or your kitchen. And anyway, what he said was, when you walk into a building or you walk down a street, even though you're not an architect, if it feels right, it has the quality without a name. So we all know good design when we see it, even though we might not be able to explain it or even explain why it makes us feel in a certain way. I I feel that cloud native definition is a bit like that. You see interoperability, programmatical APIs, etc., a bit of continuous integration. You know a cloud native system when you see it.
Yeah, exactly. And it's frustrating to people who I think crave that certainty because there's so much context involved. And you and I get called into clients who say, "What is the best technology to use for X?" And like all consultants, we all say it depends. And it does depend because it depends, like we talked earlier about the staff you've got and their experience. If they're super motivated to learn new things, then you can
Yeah.
push them further. If they're not, you might want them to evolve there. Um,
The problem is if you don't have a learning organization when you're using the cloud, then you don't take advantage of new releases of software, new releases of open source software. So it's almost inevitable that the companies succeeding with cloud and cloud native are the ones that have got a learning habit. And the other problem, by the way, Ian, with the quality without a name, is the other thing that we see in our customers is they appear to have the cloud. They do have containers and Kubernetes and continuous integration, but it's not working. It's not translating into revenue, happy customers or margin. This is what would you call it? Is it fake cloud? Is
uh,
it's cloud without the quality?
well, I suppose we're back to the ends, right? So if their end goal with the cloud, with going cloud native, was to uh, get become a product company or put new features in their customers' hands more quickly so they can be better in the market and make more money. If they're not achieving that, even though they've got some sort of CI and they're on a cloud provider, then they failed. They failed in the task, right? And I
Yeah,
think I think that does happen. We do see that. And I guess what it reminds me of is the concept of cargo culting, which I think is well
right.
known in the software industry, but I'll just briefly describe what it is.
It was well known because of Dave Thomas, the pragmatic programmer, used to do these talks. He regrets that, by the way, but we'll get onto that in a second. You explain what
Okay.
cargo cults are first of all.
So it's quite hard to explain briefly, but the scientist Richard Feynman, the physicist Richard Feynman, described uh, tribes in, I think it's the Pacific, who received payloads from US airplanes in the war, or rather, the US Army would be in the Pacific, and they would get food, and they would give some of the food to the tribes people, and obviously the tribes people wanted that to continue, so they built fake airports once the Americans had gone, with coconuts for headphones and all this sort of thing. Now, I don't know if this is actually true or it's a bit of a myth or whatever, but anyway, the point of the story is that there are people who do all the things that look like they're doing the right thing, but the
Right,
quality without a name is not there.
exactly. So it's superficial. So in the same way, the tribes people built what they thought was a runway, and in the expectation an airplane would land, people build these baroque cloud native systems. But then, of course, they don't get all the benefits of cloud native. So I always liken this to Lego. So design patterns, as Alexander, the architect, said, they fit together. So a street with a curve and a nice bus stop at one end and a bin over there, it will feel nice. Now, when a child builds a street in Lego, when a 6-year-old does that, they put they put a slide in the bedroom. There's usually no kitchen, there's no plumbing, so it's utterly bonkers. And actually, I'm sorry to say this because I don't want to upset any of our listeners, but we come across things that are completely bonkers. So you see that Kubernetes is used and you see that observability is used, but it's not used in the correct way. And so you have the cloud native equivalent of having a slide in a bedroom and a toilet on the roof. So it's
I,
all the pieces are there, but they're all in the wrong order.
I was literally talking to someone yesterday. They were talking about an application they built um, at at their work, and it was a sign up application. It was a sign up microservice, and they'd written it as an API and then put Kafka in it to talk to another system. And I was like, why do you need Kafka? And they said, well, it's so we can scale later. And my first thought was, how many people are you expecting to sign up to your service? That, unless you're working for Google or Amazon,
Yeah.
I'm not sure that your company needs that.
I mean, in the olden days, we used to talk about premature optimization was the root of all evil. You try to
Mm.
get your algorithm to be optimized. Do you remember we used to do a log, big O notation? It was
Yeah.
an x squared algorithm or an x cubed algorithm or it's logarithmic. But if you're only processing 6 records, it doesn't matter, right? So if you're only processing 600 records in a database, you really don't need to optimize that algorithm. Now, I don't know if you ever came across Axon. Have you come across that? It's a framework in Java,
No.
and it was created by a guy
AXON.
called yeah. It's I can't remember what it was actually. It was something. I don't think it was quite as awful as Spring. Uh, I think it was like a message queue. Anyway, it was developed by a guy called Allard, and he was a Dutch guy. He lives in The Hague now. Allard, if I can pronounce his surname, Bauscher. And I knew
Mhm.
Allard from community events, and he once said to me something that really stuck in my head. He said, "I don't build systems that work at scale. I build systems that can be scaled." And it stuck with me because the talk he then went on to give was about how to get the right components in that can be later be popped out and popped back in with a different version, a different message queue, a different database. And I
Mhm.
think this concept is central to what we do at Container Solutions, but it's very difficult to teach and to explain. And so we get people saying, well, it has to work out as scale out the box, and we're a bit like, but you've only got 500 users actually in your marketplace. You might
Mm.
never have more than 20,000. So what we first need to do is get it working for the handful of users you've got and then scale out. If you try to build it to address the needs of 50,000 people from the get-go, you're most likely to fail, because the lessons that you will learn as you evolve and as you scale your systems are essential to the final solution or the end solution you come up with.
We once worked with a client who had a mantra of right first time, as
Oh,
in get and
was it
maybe
sort of that idea from the tailors? You measure twice, cut once idea.
well, I think it was a reaction to um, rushing in and developing stuff quickly
Yeah,
and then
yeah,
getting it wrong. However, I mean, that is a danger, right? But there's also a danger to endlessly discussing something without
yeah,
experimenting and proving your
yeah,
concepts. So finding the right balance between experimentation, which the cloud enables, right? That's one of the great
yeah,
selling points, speed to market. Getting that balance right between experimentation and getting it right um, is very hard to again, it's context dependent because if you're building something that's very mature, if you're changing something that's very mature, you can't just dive in and change
no,
a piece of code
and
here. If it's new, you can try lots of things quickly and throw them away if they don't work.
the problem is it's a legitimate trauma. Lots of people have seen proof of concepts grow. We see POC hell, where everything's a POC and never goes
Mm.
to production. So it's a legitimate trauma. So it's a bit like, well, I want to subdue all the POCs that are sprouting like weeds. I don't
Mhm.
want to go to production again and have an outage in production. And so people tend to front load the process to try to bake quality in from the beginning. I don't think it works. I think what cloud native taught us was that you get quality and security and scalability through speed of development, through speed of iteration. But I certainly don't want to downplay the trauma that our friends in the community have had. And then the question is, then how do you, I suppose, let go of that trauma on the one hand, but bring in the right guardrails to make sure that you are evolving in the right direction, and you're not going to produce something that's not secure or blows up in production and
I
gets
mean,
you on the front page of the FT.
the thing I often see is that company X has been successful and matured in a certain way, and they get used to that mode of operation where everything is quite mature and making changes is uh, anathema. They're then stuck in a situation. It's kind of innovator's dilemma. They're then stuck in a situation where they feel they have to move to the cloud for business reasons, but they're so used to getting things right first time or planning everything carefully before they try it that they can't try stuff in this new environment. And often what we do is just bring that spirit of it's a new environment, it's a new application. You don't need to apply these same principles that you've
Yeah,
applied to your mature ones.
yeah.
And that
It's
that is
content
very
diagnosis, isn't it? It's that this is what
yeah.
managers often get wrong. They misdiagnose their own context. They're too secure when safe when they need to be risk seeking, and sometimes they're reckless when they need to be more tread more carefully. I suppose that is the job of management, isn't it? Understanding the context and choosing the next moves. Now, Ian, I would like to tell a story about where the cloud came from
Hmm.
because I think storytelling will help our listeners to understand all these weird concepts we've been discussing. Before I do that, though, I just want to add one extra thing about cargo cults. So the original cargo cults happened when Europeans first started sailing in the Pacific, and they would wreck their ships, and then boxes would wash up on islands that had never actually had any contact with European citizens. But the use of cargo cults as a metaphor has actually been sort of discredited because the cultures and the peoples of the Pacific Islands had a whole rich tradition of praying to certain gods and certain things. So I think it's now the people who use cargo cults as a sort of example often get a bit of a slap on the wrist for sort of misrepresenting the cultures that they sort of nabbed the idea from. So there's quite a controversial, well, not controversial, there's that discussion has continued and unfolded, and there's actually quite a few decent articles about that.
Yeah, I'd be happy to use a different metaphor if I found one.
Yeah, well, let's maybe we can find one and not contribute to
Yeah.
the to the controversy. Right. So coming back to speed, scale, and margin, this is a story that I love to tell because I think it explains how you go from having a few computers on premise to having the cloud. And as you learn about that journey, you start to understand why speed and scale all contribute to margin. So, do you actually know where the cloud is? I'm sure you do know this because you're my mate, but just in case, did you, or before you met me, did you know where the cloud came from and what its origin story was?
I didn't, and yeah, I didn't, Jamie. So
Are you
why don't you
bored of
tell me?
hearing this story?
I might be.
Well, that's my favourite story right now. The problem is I'm getting old, so I'm running out of stories. Okay, so basically, the cloud as we know it now, all kinds of people will claim that they invented software as a circus, software as a service. For example, Loud Cloud was a platform for running applications that predates Amazon. But if they're going to claim that they invented cloud software, then what about time sharing and mainframes and booking engines, which used to serve travel agents on the high street and then send them a monthly bill for how many times they'd logged in and asked for flight information. So, but I think the cloud as we know it was definitely invented at Amazon. And Jeff Bezos probably, am I pronouncing that right? Nobody knows how to pronounce his surname. Are they Bezos? I think it's Bezos. So Bezos is probably read a book from 1982 called The New Alchemists. And the original alchemists were Thomas Edison and his gang, who translated science into pure money, dollars. But the new alchemists basically changed sand into digital currency. They created computer technology from silicon. So at one point, Amazon, they started to succeed. They sold a very simple commodity, books. The book you have in your hand would exactly be the same as the book you'd get in a bookstore at the airport. People understood it, so they might not have trusted Amazon or the internet, but they were like, oh, well, I trust that publisher. And so they started to succeed. And the mass growth that Bezos expected actually happened. 1,000 users, 2,000 users, 4,000 users. And back then, all of these internet companies or these web companies were desperate to grab customers because they knew a customer that you would grab at the beginning of this new way of doing business would not just be a customer for life, but potentially become an intergenerational customer. So their kids and their kids' kids would use Amazon, and they were 100% right about that. So Bezos was desperate to grab land on the digital frontier. That's how he explained it. Now, at some point, they had two computers. Do you know what they were called? You do know,
Go
don't
on.
you? They were called Bert and Ernie. So do you remember back in the days when we used to name our computers? I've seen Star Wars names, Star Trek names. What names have you seen for servers, Ian?
I use artists, so I've got Bacon at home and Dali.
You've got Bacon, you've got Dali. I worked for a company that used Hitchhiker's Guide to the Galaxies. But the point is, we had machines and we gave them names and we loved and we nurtured them. And one evening, poor Bert and Ernie were chucked in the back of a car and driven across town because Amazon were changing offices. Now, when you've got access to computers like Bert and Ernie, or in your case, Bacon and Dali, um, you can get your software onto them really quickly. There are no gatekeepers, there are no procedures. You get your software onto them. So if you've got an idea for one click or to remember somebody's credit card, it goes from your machine onto Bert and Ernie, boom, like that. And then it's in the hands of your customers. That was the crazy thing about web scale development. As soon as you changed the product, it changed for every single user instantly. Great, Jeff Bezos is thinking great, so I can upgrade my web shop and the features and the usability of it as quickly as my programmers can build this stuff. That will lead to happy users and intergenerational loyalty. So of course, what happened? The computers got bigger. They had to be stored in a warehouse. They had to be fireproof and all of that. They were, in other words, a very expensive commodity. And that meant Amazon software developers couldn't get their systems, couldn't get their code onto the machines. Now, what did Jeff Bezos did? I think they call it doing a nutter at Amazon. I think every time Bezos had a fanny fit, they'd say, "Oh, he's doing a nutter." And what Bezos doing a nutter is basically he just chucks a tantrum. And his tantrum went something like this. He would run around screaming, "Developers are the new alchemists and they must be allowed to do their alchemy." This was the genesis of the cloud, because what happened next was he wrote a memo and he said, moving forward, you guys in computer infrastructure, you guys and girls in infra, you're going to serve my programmers as if they were real paying customers. So they are going to be able to order a computer with a load balancer and the right version of Java on from you, exactly like they can currently order books from Amazon.com. Get it? Anybody who doesn't obey these new set of rules will be fired. That was the very last bullet point in that memo. So from there, you get to standards. What are the things that all web applications need? Payments, databases, compute, etc. Then you start to get this idea of service. You can order it up like you order a book. And of course, once you get to servitization, if I can get that word out, then you get to APIs. So that means they could programmatically say, give me 2 computers with this version of Java. Therefore, you have programmable infrastructure a la the cloud. And then what happened next was the most amazing piece of business luck you are ever going to hear of. At one point, Bezos was at a conference with his assistant, Colin, and the guy from Flickr. Do you remember Flickr, Ian?
I do.
Flickr was a photograph. I think it still is a way to share photographs. Nowadays, that's trivial. You could use WhatsApp, Facebook, whatever. This was not trivial back in 2001, 2002. So you could take digital photographs, organise them, and share them with your mates. Brilliant. And the poor chief exec from Flickr on stage said that 50% of their engineering effort goes to the product and 50% goes to scaling the infrastructure because their users were growing constantly. Bezos and Colin are in the audience thinking, holy shit, we could do that for them easy. We've got way more users than them. We could host that on our spare tin. And then the poor Flickr guy could just focus on his product and we'll do Flickr's undifferentiated heavy lifting. The things that don't add to the product in exactly the same way that electricity doesn't really add to the product, but it's how you run your factory. And this was the business miracle. So they were like, well, if we can do Flickr's undifferentiated heavy lifting, then we could do Tesco's and Sainsbury's and Adidas's. So the idea of the cloud, which was originally created to solve the problem of creativity in Amazon, became a business idea. And this is when the luck started. It took 7 years for a competitor to enter the marketplace. Amazon had a monopoly position for 7 years because nobody thought it was a good idea or it would work. And it was all organic. So all this nonsense about research budgets and skunk works and all that, Amazon proved with incremental, sensible changes, you can actually build something hugely creative.
And what I love about that is that in the middle of it, you talked about programmability.
Programmable.
And if you go back to the CNCF definition, one thing I didn't mention was that I like the fact that it wasn't prescriptive. There are 3 words in there which I think are absolutely essential to what cloud native is. It's kind of non-negotiable, and it's programmable, programmatic, and repeatable.
Programmatic. Yeah.
And repeatable.
Yeah.
And you could say the same about DevOps. You could say the same. I mean, it's sort of common sense in a way, but I think those three words, I always come back to them if someone says that's not cloud native, I say, is it programmable, programmatic, and repeatable?
That's
And you'd
it.
be
Is it
surprised how,
programmatical and repeatable? Yeah.
yeah, and
Exactly. So what you're essentially doing is you're taking a whole warehouse of computers and working with them as if you were working on your laptop in your office.
yeah,
Right.
exactly.
Now, on that happy note, Ian, the reason I like to tell that story is because we encourage our customers to go back to basics. So think carefully, forget about Kubernetes and AI and all of that stuff. Think about your business goal. Do you have scaling problems like Amazon once had? Are you trying to improve margins? If you can answer those questions or discuss those questions, then work out, is the cloud for you? Now, of course, if you do get that far, the next thing will be you've got to do it properly, because if you don't do it properly, not only will you lose money, but you might end up blowing up your company and you'll find yourself on the front page of the newspapers for all the wrong reasons.
Exactly. So I assume we're going to be talking about that in the coming weeks, Jamie.
In the coming weeks, you've teed it up perfectly. So, in the next episode, we will be talking about the type of businesses that this works for. We're going to be talking about the startup, the scale up, and the enterprise, and how they achieve speed, scale, and margin with cloud native. And after that episode, we will slowly but surely start to get into the technologies that compose cloud native architectures. I've been Jamie Dobson. You've been.
Ian Lyle.
And until the next time, we wish you all wonderful days. Bye.
Bye bye.